Hello everyone. Today we are here to discuss a presentation on design and simulation of UART serial communication module based on VHDL. We consist of three members in our group: Sharma, Shardul, Babhulkar, and myself, Shruti Sharma. These are the few topics we'll put lights upon. Coming to the introduction, as we all know, the UART stands for Universal Asynchronous Receiver Transmitter. It is a kind of serial communication protocol mostly used for short distance, low speed, low cost data exchange between computers and peripherals. For reliable data transmission, serial communication is very effective than parallel communication. Asynchronous serial communication has advantage of less transmission line, high reliability, and long transmission distance. Therefore, it is widely used in data exchange between computers and peripherals. The UART allows full duplex communication in serial link, thus has been widely used in the data communication and control system. In actual application, usually only a few key features of UART are needed. The basic UART communication needs only two signal lines, RXD, TXD, to complete full duplex data communication. TXD is the transmit side and it is also known as the output of UART. RXD is the receiver, the input of the UART. UART basic features are there are two states in the signal lines using logic 1, which is high, and logic 0, which is low, to distinguish respectively. This was the meaning of the above diagram. Now the next slide will be explained by Harsh Sharma.
Thank you, Shruti. I will be discussing the technology used in the paper. The UART serial communication module is divided into three sub-modules: the baud rate generator, receiver module, and the transmitter module. The baud rate generator is used to generate the clocking mechanism required for communication and is actually a frequency divider. The receiver module and the transmitter module. The transmitter and receiver line for each device is to transmit and receive serial data intended for serial communication. The UART receiver module is used to receive the serial signal at RXD and convert them into parallel data. The UART transmit module converts the bytes into serial bits according to the basic frame format and transmit those bits through TXT. Next slide. Now we will discuss the innovative concept of this paper. In this paper, we have used a finite state machine, and the state machine includes 5 states. The states are R start, that is waiting for the start bit; R center, which finds the midpoint; R wait, which waits for the sampling; R sample, where sampling is done; and R stop, where we receive the stop bit. Now I will be discussing these 5 states. Talking about R start status, when the UART receiver is reset, the receiver state machine will be in the state, and in this state, the machine has been waiting for the RXD level to jump over from logic 1 to logic 0. That is the start bit, and this alerts the beginning of new data frame. Once the start data is identified, the state machine will be transmitted to R center state, because when sampling logic 1 or logic 0, we do not want the detected signal to be unstable. Talking about the R center status, for asynchronous serial signal, in order to detect the correct signal each time and minimize the total error in the later data bit detection, in this state, the task is to find the midpoint of each bit through the start bit. The method is by counting the number of blocker. In addition, the start bit detected in the R start may not be really start bit. It may be an occasional interference sharp pulse. This interference pulse cycle is very short. Therefore, the signal that maintains logic 0 over 1/4 bit time must be a start bit. Talking about the R wait status, when the state machine is in this state, it waits for the counting blocker to 15 and then enters to the R sample mode. Then talking about the R sample mode, R sample is the state where the sample data bits reach the 16th blocker. At the same time, determining whether the collected data bit length has reached the data frame length. If it reaches the data frame length, it means the stop bits arrives. The frame length is modifiable. In this design, it is up to 8, which corresponds to 8-bit format of UART. Talking about the R sample status, here data bit sampling is done, and after sampling, the state machine transfers to R bit staged unconditionally, and it waits for the arrival of the next start bit. And the last status, that is R stop status. Here, the stop bit is either 1 or 1.5 or 2. The state machine doesn't detect RxD in the R stop, but output frame receiving done signal, that is 1. After the stop bit, the state machine turns back to R start state and waits for the next frame start bit. The next slide will be discussed by Shardul.
Limitations of the paper. It uses less number of lines for transmission between devices. Hence, it supports low speed of transmission. Wastage of bandwidth means for the data transmission for the useless stuff. It requires specific knowledge of the structure and the syntax of the language. It is more difficult to visualize and troubleshoot a design. A code is difficult to implement and time consuming. Now, we have the results of the paper. Starting for the results, firstly, we should know the simulation software. So in this particular paper, we are using a simulation software called as Quarters 2. Talking about the baud rate generator simulation. During simulation, the clock frequency is set up to 32 megahertz and the baud rate is up to 9600 bps. And bps stands for bits per second. So therefore, receiving sampling clock frequency generated by the baud rate is about 153,600 hertz, which is 16 times of the baud rate. Now coming to receiver simulation. During the receiver simulation, the receiving sampling clock frequency generated by the baud rate generator is set up to 153,600 Hz. UART receiving baud rate is up to 96 bps. The input sequence 001101100001, including the start bit with 0, parity bit with 0, and 1 stop bit. Coming to the transmitter simulation. During the transmitter simulation, the sending clock frequency generated by the baud clock generator is set up to 153,600 and UART remaining baud is up to 9600. Now we have the conclusion. This design uses VHDL as a design language to achieve the modulus UART using Quarters 2 software to complete the simulation and test. The results are stable and reliable. The design has a great flexibility and high integration with some reference value, especially in the field of electronic design, where SOC technology has recently emerged and become successful in today's era. Thank you. Now we have the contribution of 3 members. So in our group, we have 3 members, Harsh Sharma, Shruti Sharma, and myself, Shardul.